one-dimensional motion. Okay, one-dimensional motion, linear motion. And we spoke about distance, displacement, velocity, acceleration, and its twin brother, deceleration. What is motion? Quick one. What is motion? Yes, go ahead, Florence. Go ahead.
Motion is when the position of an object changes over a certain period of time.
Okay. Okay. So motion is characterized by the change in position of a body. All right. What is distance? Quick one. What is distance? Yes, go ahead. Go ahead and contribute.
Distance refers to the interval measured between 2 points.
The magnitude of the length between 2 points in a straight line. Okay. Then displacement. Okay. Okay, go ahead.
Displacement is the distance covered in a specified direction.
So the distance covered in a specified direction is displacement. Bushra, what is speed? What is speed? Okay, Stoneboy, go ahead.
Speed is the rate of change of distance with time.
So the rate of change of distance with time gives us speed. Okay.
Yes.
Then velocity. Velocity. Hey, Yaba, velocity. No, Yaba is not here. Okay, Florence. Florence.
Velocity is the rate of change of displacement with time.
So velocity is the rate of change of displacement with time. Gloria, how different is speed from velocity? How are they different?
With velocity, there is a specified direction, but with speed, there is no direction.
Good. Then, Zuvia, are you here? Zuvia,
Yes, please.
acceleration. Acceleration.
Please, acceleration is the rate of change of velocity with respect to time.
So how velocity or speed changes with respect to time gives us acceleration. Why do we say acceleration is positive? Okay, go ahead. Okay, Watima. Why do we say acceleration is positive?
Acceleration is positive because the initial is always 0. So as it moves, it increases. As the body
Akuya, you are right, but not to some, wrong to some extent. The initial cannot always be 0, but the fact is that the final velocity is always greater than the initial velocity. So when you find a change, it will give you a positive value. Is that okay? The initial can be 0, the initial cannot be 0, but the final velocity is always greater than the initial velocity. This is about an increasing speed or velocity. Okay, so velocity may start from a value, it can be 2, it can be 3, but as time goes on, the velocity or speed will be increasing. So the final is always greater than the initial. Are you okay? And since acceleration A is equal to change in velocity with time. The change v minus u on t. So because the final is always greater than initial, the change v would be equal to a positive value. Please, are we okay? Are we fine?
Yes, please.
Go.
Yes, please.
Now deceleration is negative because here the final v is always less than the initial. So if the final is always less than the initial, when you are calculating for the change to determine the acceleration, the change is always v minus u. But here is the case, the final is less than the initial. So certainly this will give you a negative value. All right, so that the acceleration, so that the acceleration A would be equal to negative value of V over T. And so here in this particular case, the acceleration is negative. And when acceleration is negative, we are saying that the body is decelerating. So its speed is decreasing to a stop. Are we fine? All right. Then yesterday we also learned about a uniform velocity motion. What is a uniform velocity motion? Let me go to the far end of the class to call participants. The far end of the class. Okay, Elikem. Lydia Ekuya Odro. Okay, if you are ready with it, please go ahead. What is uniform velocity motion? Uniform velocity motion.
A uniform velocity motion is such that a body covers equal distances over equal time intervals.
So within, don't use over. Within, okay.
Okay, within equal time intervals.
Exactly. Okay. So the body covers equal distances or within a specified direction within equal time interval. Okay. Or it can also be put at a uniform velocity motion is obtained when the rate of change of displacement, okay, with time is constant. Okay, when the rate of change of displacement with time is constant, then the body is in what? Uniform velocity motion. So we plotted a displacement time graph or velocity time graph, sorry, displacement or distance time graph. So S, I'm coming, S, which is the distance or the displacement, and then the horizontal independent variable is always time. And when the motion is such that the rate of change of displacement with time is constant, or the body covers equal distances within equal time interval, when you plot such a graph, this is what you have. The slope of such a graph, which is the change in displacement or distance over the change in time, this slope will be equal to, yes, what does the slope of a displacement time graph amount to? Or what does it give us? The slope of a displacement time graph would be equal to, yes, quick one.
Velocity.
It will be equal to the velocity.
The velocity.
Okay. And we say that this velocity is uniform. Hence, the velocity is uniform. Hence, the name given to such motion, uniform velocity motion. It means along the straight line, the velocity is uniform or constant. Hence, the name uniform velocity motion. So the concept length is that on a displacement time graph, the slope would give you the slope would always give you the velocity of the motion. And when it happens that the body covers equal distances within a specified direction within equal time interval, then it means that the body is described to be uniform velocity motion. Florence, if you have a question, quick one.
Can you give the other meaning for the uniform velocity motion?
Oh, Florence, I can't hear you well.
The other definition for uniform velocity motion.
When the rate of change of displacement with time is constant. The other definition, we have a uniform velocity when the rate of change of displacement with time is constant. So that's it. Now we can also have a situation where the distance covered in a specified direction by the body may not be within equal intervals. The time can be equal. Let's use data to explain this. So let's quickly use data. 1, 2, 3, 4, 5. So this is displacement time. So time 0, 1, 2, 3, 4. Now displacement 5. At this is maybe 8, 10, 15, 18, or even 20. What do we see? Here the time, okay, is within equal intervals, 1 second each. But the distance covered by the body isn't within equal intervals. Even though the distance, we have a situation of increasing distance by the body. Now, when you plot such a graph, when you plot such a graph, the distance covered against the time axis, the independent variable time. Let's sketch something to plot. We have 0, 0 is here, 1, 2, 3, 4. Then 2, 4, okay, let me use 5, 5. So 5, 10, 15, 20. So at time t is equal to 0, time t is equal to 0, this must go with 0. Okay, it means you haven't started the journey. So time isn't moving, and so the distance covered is also 0. So at time t is equal to 0, this is 0. Distance covered is 0. Time is equal to 1. The distance covered is 8, somewhere here. Time is equal to 2, 10. Somewhere, you left it somewhere here. Time is equal to 3, 15. Time is equal to 4, 20. In fact, when you plot such a graph, this time you will not get a straight line. You see, I just figured some values out to represent the data. But in actual situation, when you have such a graph and the time or distance interval isn't accurate, okay, consistent, you have a curve. This one doesn't give us a clear value curve because of the choice of the values. But when you have a situation where the distance doesn't covered isn't within equal intervals, you have a curvy something. You have a curve. Please, are you okay? Are you okay?
Yes,
Yes, please.
So for non-uniform velocity, sorry, displacement graph. For non-uniform velocity graph, it's a curve. It's a curve. Okay. When you have the distance covered or displacement by the body not within equal intervals, the graph gives you a curve. Now, the moment here, because it's a curve, this is a curve, you can't find the slope, a uniform slope for the whole graph or motion. You can only determine slope at some point or instant. So if you want to determine the slope at the time t is equal to 2, you draw a straight line, what we call as a tangent, to determine the slope at that point. If you want to determine the slope at the time 3, you draw a tangent to determine it. Okay, so under non-uniform velocity motion, you can only get what we call instantaneous velocity. And what is instantaneous velocity? Instantaneous velocity is velocity within a given time, or within a set time. Because the graph is a curve, you can't have a uniform velocity for all of them, but you can only determine the slope which represents velocity within a given time, hence the name instantaneous velocity. Are we okay? Alrighty?
No, please, Mr. Edia, can you repeat it?
All right. Quick one. You see, when you are plotting the motion whose displacement doesn't occur within equal intervals. Over here, the time interval equal 1 second each, but the distance covered in that specified direction doesn't come within equal time intervals. And when you plot such a graph, you have a curve. You have a curve. Because you have a curve, when you find a slope, it won't give you one value, one uniform value as we got here. Are you okay? And so you can only determine the slope which represents velocity within a given time. Maybe at 2 seconds, I want to determine the slope. Don't forget the slope will give you velocity. So if you want to determine the slope within 2 seconds, then you are looking for the velocity of the body within 2 seconds. Maybe 3. You pick, oh, let me find the slope of this curve within 3 seconds. Then it means you are looking for the velocity of the body, moving body within a time 3 seconds. So when you have such a graph, you can only determine the velocity within a given time, hence the name instantaneous velocity. Are we fine?
Mr. Edia.
Are you okay?
Mr. Edia.
Hello?
So when you are doing the instantaneous velocity, you take like 2 points or you use just one, you just subtract, for instance, the 5 from the 2 and you get it.
You consider 2 because you
2 of
find a
them.
change. You consider the change in this. We'll be solving questions under this. So when we get there, we'll look at how to find instantaneous velocity. All right.
Okay, thank you.
But the whole idea I want you to understand is that if you have a okay, all right, before then. So we realize that the velocity at a time 2 seconds will be different from the velocity at a time 3 seconds. The velocity at a time 4 seconds will also be different from the velocity at a time 5 seconds. But because the displacement, distance covered is increasing, okay, it means that the velocity at 1 second will be less than the velocity at 2 seconds. The velocity at 3 seconds will also be greater than the velocity at 2 seconds, on and on and on. So we have different velocities as we move on. And this, because the velocity will not be uniform, we describe this as non-uniform velocity motion. Okay, we describe this as non-uniform velocity motion. In this particular case, because the velocity along the straight line is uniform, that is why the graph is named as uniform velocity motion. Over here, it is non-uniform because the velocity at a time 1 second is less than the velocity at a time 2 seconds. On and on and on. And the velocities are not the same. Hence the name non-uniform velocity motion. Please, if you have any question, quickly ask and let's continue. Okay. So if you pick any 2 points, assuming we are picking 3 and 2, the velocity at time 3 seconds obviously will be greater than the velocity at the time 2 seconds. All right. Equally, velocity at a time 4 seconds would also be greater than velocity at a time 3 seconds. Okay. And because of this increasing velocity along the curve, we say that when a body is in non-uniform velocity motion, the body accelerates. So a body in non-uniform velocity motion accelerates because of increasing velocity along the curve. A body in non-uniform velocity motion accelerates because of the increasing velocity along the curve. Please, are we okay?
Yes, please.
Then let me pick your brain on this. What will you say Okay. What will you say about the acceleration of the body in a uniform velocity motion? Yes, Ekuyabuatima.
It is constant.
The acceleration.
The acceleration is steady or constant.
Why? Why are you saying it's steady or constant?
Because the acceleration is equal throughout.
It's rather the velocity that is equal throughout, isn't it?
Yes, please.
But what is acceleration? Acceleration A is equal to change in velocity over time. So if the velocity is constant throughout, what will you make of acceleration of the body? Yes, somebody else should come in. Yes, we are sharing ideas. If the velocity is constant at any given time, then what will you say about the acceleration of the body here? Hello, Akosia. The acceleration is zero. The body doesn't accelerate. And the body does not accelerate because, you see, at every point, the velocity is the same. So if you pick any 2 points, this point and this point, okay, maybe a time of 1 second, a time of 5 seconds, and you want to determine the acceleration. The change in velocity, okay, is zero because the velocity at this time maybe is x. The velocity at this time is also x, but the change is the final minus initial divided by the time 5 minus 1. So yes, there will be value at the denominator, but the numerator is zero, and because of that, we say a body with a uniform velocity has a zero acceleration. Are we okay? Hello, class. Are you okay?
Yes, please.
So a
Yes,
body moving with a uniform velocity, okay, or constant velocity has a zero acceleration. However, a body moving with a non-uniform velocity accelerates because at every point or at every instant, the acceleration there, the velocity there is greater than before. So when you subtract, there is a change. Okay, and once there is a change, you have a value for the acceleration. So a non-uniform velocity, in non-uniform velocity motion, the body accelerates. In a uniform velocity motion, the acceleration of the body is zero. Okay, let's look at another graph. We are still under displacement time graph. This time, what we have is this. Let me change the data. We have 20, 15, 10, 5, and 0. What is happening? What is happening to the displacement of the body? Yes. What do you think is happening here? Yes. What's the observation? Go ahead. Anne, go ahead. What have you observed?
Reducing by 5.
The body's
It's reducing by 5.
okay. So the
The
body's displacement, okay, decreases within equal intervals with equal time as well. All right. And when you plot such a graph, zero, 1, 2, 3, and 4, 5, 10, 15, and 20. At a time t is equal to 0, the distance covered or the displacement is 20. At a time t is equal to 1 second, the distance covered is 15. At a time t is equal to 2, the distance covered is 10. 3, we have 5. And then at a t of 4 seconds, we have 0. When you plot such a graph, you have a straight line. You have a straight line. And the slope of a displacement time graph is always equal to the slope of a displacement or distance time graph is always equal to, yes,
The velocity.
but look at this velocity. So the formula for we have to pick any 2 points, change in the vertical against the change in the horizontal. That's a change delta S. This is delta T slash S. So we have delta S slash M over delta T slash S. Now, in determining the change, we are always considering the difference. Okay, what is the final displacement of the body per what we've chosen? The final displacement of the body per our 2 points is 5. So this side we'll read it this way. Then the initial displacement of the body is 15. When you divide, what's the time? Change in time. Okay, the final time is 3. The initial time is 1. When you subtract, you have minus 10 on 2, which is equal to negative 5 meter per second. In such a situation, the slope is a negative slope, meaning that the velocity of the body is negative. The body's velocity is reducing within equal intervals, okay, but or to a stop. So this is also another example of uniform velocity motion, but this one happens when the body's displacement decreases within equal intervals with time as well. And when this happens, the slope is a negative, and so the velocity is a negative. If you have any question, quickly ask so we can move on. Any question? All right. Then let's continue. So this is another uniform velocity motion. But here, because the distance covered by the body is decreasing with time, the slope, which is equal to the velocity, is a negative 1.